Okay, hello everyone. Welcome to the first Waylay Autoshop. In this podcast kind of format, we'll try to solve use cases in the IoT world or just data automation world. And today we will be talking with me, Sander van Hoof. I'm the community manager at Waylay, and I generally do community things. And of course, my guest, Arabinda, who is the CTO of Waylay North America. Arabinda, can you talk a little bit about yourself?
Sure. Hi, everyone. My name is Arabinda Bose. I'm the CTO of North America for Waylay. I recently joined this company after a long career at Nokia and Alcatel-Lucent. I live in Austin, Texas. My role and responsibility is to make the technology strategy, talk to customers, understand different types of use cases, and work with product management and engineering to build very good products, such as Waylay's platform.
Yeah, exactly. And today we are going to talk about a very interesting use case, which is building safety and disaster prevention. So recently we've seen some horrible examples of building maintenance that has gone wrong. The process of investigation is still ongoing of what the causes could have been for these buildings collapsing in Miami. But we thought we could maybe try and tackle this use case using the Waylay platform and do some building monitoring in general, because that's very important, definitely in a country where there are, I think, a lot of earthquakes, right, Arabinda?
Yes, definitely. But first, my heart goes out to people who lost their lives in Miami building collapse, and also people who are living and friends and relatives. It's a horrible disaster. I hope this kind of things will not happen in the future. And also many people have lost their lives around the world. When this Miami building collapse happened, I was also looking at how many buildings and bridges and metro passes and others have collapsed is horrible. In 2021 itself, there has been disaster there was an apartment collapse in Cairo, Egypt. There has been a metro pass collapse in Mexico City. Then Miami happened. And also there were other disasters that happened around the world, including in India and also in a hotel collapse in China. So it is very prevalent across the world. And generally the disaster areas are where there are either a lot of rainfall and mountains, or there are earthquake prone areas, or there are seaside condos where the salty air and also the buildings.
Where it erodes.
Sorry?
Where it erodes, probably, where the...
Yeah, and also the soil level, right? If the soil level is very soft, it also sinks. Those kind of things happen, and there are many different ways to prevent them. And we'll talk about that throughout our discussions here.
Yeah, exactly. So the use case I wanted to mainly focus on is vibration detection. So in building maintenance, you have to look at damage from vibrations, for example, earthquakes. And you can detect these vibrations using different sensors from different manufacturers with each their own cost and their own general how do I say this, their accuracy, of course. But in general, most of these measure two things, which is the level or velocity of a vibration, which is the measure of how fast it is, or how much distance it is covering, right, in millimeters per second. And then you have the frequency in hertz, so how fast it is oscillating by itself. And I found this damage threshold curve where an article tried to plot out which hertz and velocity combinations are dangerous for a building. Now, these are for residential buildings. These are not for towers or anything like that. So if you want to use this solution for something different, then certainly get your data straight and your measurements. But this article was talking about when you have a hertz range of 0 to 20, then minor damage will be done at 30 millimeters per second, while major damage will be done at 60 millimeters per second. And then they defined that for different hertz ranges. Because, of course, a building has a different resonance frequency or every building has different resonance frequencies and different velocities at which they will be damaged.
True. And I also saw another article where they were showing, when a building collapses, where, there are measurements at the base of the building, or if there is a vibration, or if there is an earthquake, or if there is a storm, the base of the building will move a little bit. But when it is the more stories you have on the building, then it will move more, right? So, so it needs to be measured almost every floor, how much of movement it's happening vertically, and also horizontally, how much of velocity it is moving.
Yeah, definitely. And these velocities that are defined over here are in 3 dimensions. So if in any axis there is a movement of 30 millimeters per second, then this case, the minor damage is happening. That's how it's defined over here. Yeah. And there are, of course, different ways of preventing that with pendulums and more weights or whatnot. But we are not going to look at that. We're just going to look at when you detect these values, then somebody, of course, has to go in and look at the building and have, just examine it again to see if any damage really is done.
Yeah, and continuous monitoring also. And that's the use case that you're going to show today, right?
Yes, exactly. So from the moment that the data comes in, we are going to check this and notify the right people if some spikes were detected, for example. All right.
Good.
I think we can just jump into the use case then, or jump into implementing our use case.
Oh, that'll be great.
Awesome. So the first thing I do when I create one of these use cases is mostly define the resource. So in this use case, there is only one resource, and that will be the building where we get our data from. So I'm quickly going to create that one. Let's call it vibration building. I put a space in there. All right. And then I would define how the data comes in. So in Waylay, you can easily send messages to try out sending messages to the platform and to mock data coming in. So we're going to use that for now, so we can easily get some data into the platform. And so how I imagine data coming in is we have a hertz value. For example, if we take one out of the ranges we have defined here, so for example, a hertz of 10, we have a velocity value which is, for example, 30. And here, so the hertz is at 10 and the velocity is at 30 millimeters per second. And then we can send that and have a look at how that looks. So then we'll see that these metrics are created under our building resource. And we can also see how the message is coming in. And yeah.
And you can keep also different types of resources, and you can keep some relationship between those resources. And
Yes, definitely. So, for example,
things are complex in the real world, right?
yeah, exactly. So if you have multiple sensors, for example, multiple vibration sensors, like you said, maybe one on every level of a building, you
Yeah.
can have a resource that is the building, and then have child resources that are the sensors on each floor, for example.
Okay.
So that's how I would structure that, and that's definitely
It's like a digital twin or something, where you can actually create a twin of a building or a mall or a airport or a structure, bridge. Right?
Yeah, exactly. Yeah,
Okay.
exactly. And if you have different, you can also have, for example, a building, and within that building you have a child resource, which is a room, and then you could have in that room different sensors, like, for example, temperature, humidity, a sensor that detects the amount of people within the room.
That's awesome. Yeah.
Yeah, you could build out a whole tree of
Yeah,
resources.
it can be a very complex system that we can build it in. Okay, very good.
And model of very complex systems. Okay, so we have data coming in. Now what we want to do is, act on the data coming in, right? We want to be able to notify the right people. And I don't know who would you all want to notify in a situation like this, like the building owners or authorities?
And there could be multiple stakeholders in this game, right? Depending on what it is. If it is a building, building management companies are there. Definitely fire and public health for safety. Then it could be that they may choose to also inform the building owners, because there may be people who bought the building, there may be people who are renting the building. It depends on the severity, right? If it's a low severity, you don't want to say to everybody, but if it's a high severity, you definitely want to inform everyone. And also then after that, it could be insurance company, it could be construction company, it could be department of geological survey also, like people who want to be notified in this kind of situations to understand what's happening. And in case of bridges, roads, let's say you have a vibration because there has been rain and now there is vibration and there are rocks falling on the road, it'll close the highway. So you may want to notify the Department of Road Transportation and Safety. So it depends on the situation.
Yeah, exactly. I think.
And if the platform is flexible, then you can configure different rules based on different use cases.
I think you raise a good point with the roads there, because you don't always want to only notify somebody. You also could have a rule that just cuts off the road automatically, for example, if you have boom gates on each end or something.
Exactly.
Yeah. So first we want to check if our hertz value is within one of these ranges, right? So we'll go and check if our frequency, for example, is between 0 and 20. And for that, we use a range sensor, the in-range sensor. So here, a range sensor is, we can just, define a range of values, for example, 0 and for lower limit, and for the upper limit 20. And then to make the template generic, we are going to use declarative binding, which will bind values on runtime. So we are going to get the stream data, which is the data of our incoming data, and then we get the hertz. Of course, is the hertz over here, so we have to take the same name, and then we have to bind our dynamic resource. So this will say, okay, take the resource that is associated with this task. Oh, okay, it's saved. All right. I'm going to rename this a bit so we know what this sensor is doing from just seeing the name 0 and 20. Oops. There we go. So this one will just check if our value is in range, below the range, or above the range. And we could already quickly test this out, so we know that it's doing what we want it to do. So what I'm doing is just defining a reactive task based on this very, very small template and initiating it on our vibration building.
Yeah, because this vibration data can be coming very fast. The measurements have to be sometimes in seconds or milliseconds, sometimes, of course, in minutes and hours, but it needs to be taking a lot of data. And you are giving in some format here, JSON format?
Yeah, exactly. This is you can send data to us in many different ways, and one of that is JSON. And JSON is just a JavaScript object notation, which is very standardized, and it looks like this. So you have curly brackets, and then you have a list of string. You have a string with a colon, and then the value of the metric.
Yeah, very simple format to provide the data. That looks good.
Yeah, exactly. So if I send this data, we should be able to see that our sensor over here, our node, is highlighting one of the states, and that is because I pushed a hertz of 10 hertz. So I pushed 10 hertz, and this is looking for a value between 0 and 20, which is in range. That's going great already.
I like that it highlights the blue color on the top. It's kind of interactive.
Yeah, you can directly see what's happening, right? It's very observable, as we would call that.
Yeah.
All right. So now that we know in which hertz range we are, we can start defining the ranges for our minor and major damage. So first, what I will be doing is create another range sensor, and I'm going to check the value of the stream data again, but this time the velocity. And check if it is within the range of 30 millimeters per second and 60 millimeters per second. So the lower is 30, the upper is 60. I'm again going to bind the resource that is bound to the task. And I'm of course going to connect it to the in-range state of the previous node, because we only want to check these two conditions if we are between 0 and 20 hertz. The others have different values, which is very important. I'm going to give this name again. Velocity in range. There we go.
And these nodes that you are just putting and tying together, they have some scripts behind them.
Yeah, that's
Or
interesting.
it could be some scripts behind them if they are complex.
Yes, indeed. So that's a good question. Every node you see here is just a little bit a snippet of JavaScript code. So if you want, you can just update them. You can write a new, behavior, or you can write a completely new sensor or node and use that one in your rules as well, which is very flexible.
Yes, it is.
Okay, so we have our next range sensor, and now what all we have to do is throw alarms, of course. And for that, we use the create alarm, or we can use the create alarm sensor. And I'll connect it with the in range of the velocity plugin. So if it is in range, we have like minor damage. So we can have a text that says or damage detected. Oops. Exclamation mark because it's important. With a type of minor damage.
It's actually very handy, more like a low-code type of platform where anybody can just pull all this together and just fill up the form. It's like,
yeah, exactly. So you don't have to memorize the codes. Yeah, right.
I like that part.
If you write code, you have to memorize everything. But here you just look for the name of the plugin you want to use, and then everything is there ready to fill out.
Yeah.
And then here for the resource, so you can throw alarms for certain resources. For the resource, we are again going to use declarative binding, but now we are going to get the resource name or the resource ID from the task that is triggered. So, and it's you do that like this. So task.resource.
What's a declarative binding that maybe you want to clarify for everyone?
Yeah. So declarative binding binds values on when the task is run. So for example, the stream data that is coming in, we can take it and fill it in from the moment the task is running. So for example, if I push a data point, for example, for a velocity of 30, then this value will be interchanged for the value 30. And that will be used in the plugin itself for the execution.
Makes sense. So basically, at runtime, it will take the right value and substitute in that variable.
Yes. Yeah.
Just okay.
Exactly. It will just substitute it.
Yeah.
Okay. So gonna rename this one. Create minor alarm. Create a minor alarm. And then everything that's above this range is, of course, within our major damage range. So we can just hook that up with a new alarm. Set the text to I don't know what did I set the text here for. Just gonna copy this one and say major damage detected. We set the severity to major, of course. Type major damage, and then we use the same declarative binding as we did over here. So which takes the task's resource. There we go. And I'm gonna name it properly as well.
It's very easy to create a simple model, and you can also replace those actions with some of the sensors or what you have on the left side, all the actuator sensors. Um,
Yes, yes. So we have a whole bunch of integrations on the left, and you can all use them here uh, to create a sort of rule. Of course, this is a very simplistic use case, but we can do a whole bunch of complicated stuff if we want to.
and customers can create their own sensors into our library also.
Yes, like I showed previously, so you can create these, you can alter sensors and plugins, but you can also create your own. So if you go to the plugins tab and add plugin, and you say my cool plug, create one of those, and then you get some boilerplate code and some, or
Wow.
yeah, it's more like an example actually.
That's very nice because you start from a boilerplate. You don't
Yeah.
have to start from scratch, and you can also edit and test on the console itself, right?
Yes,
That,
yes.
yeah.
You can edit right here. You can add states, add input and output properties, even dependencies. So if you have an npm package, which you can install using npm, you can just define them over here and give the name, the version, and then we will install it for you, and it can make use of that.
That's very handy.
Yeah.
That's it's a really low code type of environment. That's very nice.
Yeah, exactly. Exactly. So now we have this little rule, and yeah, I mean, let's just test it, right? So now the debugger is running like before, and let's send a new message with a hertz of maybe 10 again, and a velocity of 10. So normally this would not cause any damage because we are beneath our minor damage velocity. Let's have a look what this does. And then we indeed see that our hertz was in range, but our velocity was below range, and we don't create an alarm. Awesome, that's working. Should copy these messages and instead of typing them out every time. Velocity of.
It'd be nice to have a copy paste functionality, maybe.
Yeah, maybe that's a good thing to look into.
Yeah.
Okay, so now I pushed a velocity of 30, or I think I pushed one of 40 actually. Let's refresh. Yeah, of 40. And we see that the hertz was in range, the velocity was in range, and we created a minor alarm. So if we go have a look into our resource under view alarms, we should be able to see our minor alarm, minor damage detected.
That's cool.
Yeah, exactly.
And then you can, that's the alarm management. All the alarms will show up. You can do queries also, and
Yes.
someone can monitor, clear, do those kind of stuff in that alarm management.
Yes, yes, exactly. So you can, if you have an alarm, you can acknowledge it, which just means, hey, I've seen it. Maybe I'm handling it. You can resolve it, which means it is resolved, or you can delete it, which feels like ignoring,
Yeah.
which we don't want.
No, we don't want that.
No, exactly. And let's test the last combination, which is the major alarm. If we go above a velocity of 60, then we see our velocity is above the range, and we created a major alarm, which also should show up over here. Major.
Nice.
Awesome. And of course, these alarms could also be substituted by the things that you said earlier, where we email people.
You can email, you can open even if you want a building inspection to send field technicians, you can also open a case ID, right? To
Yes,
integrate with the field service technician,
yes.
building
For example,
safety
yeah,
technicians. Yeah,
exactly. Or you can use Twilio. So Twilio can be used to send text messages or do calls to people.
makes
So,
sense, because if it is a very high severity alarm, you want to actually call. No, that's a good point.
yeah, exactly. And then if something really bad is happening, your house is calling you.
Yeah.
Let's stop this one. We can delete these. Right. So this is one thing that is awesome to have. So you can be uh, notified when the building may be uh, dangerously
Vibrating.
vibrant, for example. Could be an earthquake, could be a
Yeah.
landslide, or could even be like if you're in a factory and you have a lot of machines running at the same time. That could also be dangerous, I would assume.
I also see that you have a building and then there is a major construction of another building going on the side. That could also be a lot of vibration coming in into your building. And I live in a place in Austin where there are a lot of limestone beds in Austin, Texas, and there is a limestone quarry nearby, and these guys use very heavy equipment to go through the limestone, and that vibration, and sometimes they use dynamites to
Oh,
blast.
really?
Yes, and so the whole nearby area used to get that vibration. Luckily there are no very high rise buildings here, but yeah, it could be something happening in your environment that could get in vibrations.
Yeah, exactly.
Having those vibration sensors is very important to measure.
Yeah, and do you think that the lack of high buildings is because of the quarry, or?
It's just a suburb, so there are a lot of homes here, and the homes are generally one or two storied. And I think the city also has some guidelines. They cannot build very tall buildings nearby where they blast with dynamites, all these quarries, limestone quarries. But now that quarry has become such a big hole that they might actually build a big building there in keeping that as the base.
Really?
There's a lot of discussion going on what they should build with that. But what I wanted to say is that it could be that there are vibrations happening around because of constructions, because of other buildings, and maybe another building has been demolished, and
Yeah,
then that can happen. Uh,
yeah,
and
exactly.
the usage shift towards road transportation, where this can happen through a lot of rain or a thunderstorm, storm, hurricane, those kind of things. There's plenty of use cases.
Yeah, exactly. I think monitoring for maintenance can be very broad indeed.
It
Yeah.
is. It is.
Like for example, in the start of the episode, you mentioned corrosion,
Yes.
where the water could take away the soil underneath the building. Um,
Absolutely. And then you can have not only just the vibration sensors, and that's probably something you may want to tell or clarify. Like, say, for example, you have vibration, you have a tilt sensor, you have
Mhm.
moisture sensor, you can have all kinds of sensors attached, right?
Yes,
And based on different conditions, it can take actions.
yes. For example, you could, yeah, just make this network a lot bigger with different scenarios and different um, ways of interaction of these variables, right? Because now we have two variables and we already see that they have a lot of different ways of interacting. So I would imagine that a tilt uh, variable would, yeah, give this little list already a second or another layer of complexity where you want to have different velocities, or you have different hertz ranges for different tilt levels, for example.
Yeah, yeah. And also, it doesn't have to be always through data coming through sensors, right? Can you have APIs calling into other systems and getting that data while making decisions?
Yes, yes, of course. So, for example, if you have somebody on site who can provide data, who can say, okay, the building looks okay. In that case, we will be less harsh on which values we set as thresholds, for example.
Yeah. And I was also thinking about a situation where maybe there has been an inspection already on that building by a construction structural engineering team. And let's say they have found 5 issues that they had raised. Oh, there are damages to the parking lot, or pillar or load bearing columns. And then you see these vibrations. We should definitely escalate that, because they had recently done and they had found this, and now you have a vibration. We should now raise a high severity alarm that there has to be action now.
Yes, yes, exactly. Yeah. Yeah, it's totally possible to just throw an alarm using APIs without using the rules, for example. That's also possible.
Yeah,
Okay.
very nice.
So I think if we have our automation, we may also want to visualize our data, right? We could, I can see homeowners want to have a dashboard of their sensor.
Absolutely. Like an end user type of dashboard, you're saying,
Yeah,
for the
exactly.
stakeholders.
Yeah. So so they can see what vibrations were happening, or if there were any alarms thrown that day. And for that, we have a different tool. So we have our dashboarding tool, where you can create a new dashboard, which I'm going to call house, for example. I see my settings are in Dutch, so let's put them in English. So I created a new dashboard for the house, for our little house. I will have to add our house. So we do that through a metadata key that's called customer house. Add over there. We'll also have to create a group. We'll also call house. There we go. And this should create a new resource, this one. And now we just have to associate our vibration house. So what we do is set the parent ID to the ID of our group. And then we will see that our vibration building has one parent house, and our house has one child, which is the building, of course. And in our dashboarding, we will now see that the group house has the vibration building, which is what we want. And now we can start creating a dashboard for it. I'm thinking about adding a GAUK. So
Yeah. So can you tell a little bit about the dashboard? Like, what is it? Is actually one can create this dashboard by just picking stuff and building it? That's what you're going to do?
yes, yes, exactly. So you have a lot of different widgets, and you have a nice blank page which you can use to put these widgets on. So you can have a nice graph of the time series, or you could have a map if you want to show a map of the location of your resource, things like that. And yeah, we're just
Right.
able to create our own dashboard and our own visualizations.
All right, show me a dashboard.
Okay, let's go. I think the first one that could be a good one to show is time series, because then we can see how the values evolve over time, and we can easily show, for example, the velocity and the hertz. What we also can do is maybe we can put them on different axes, because now we see that the velocity is kind of taking over the axis while our hertz is down at the bottom.
Mm-hmm.
So I'm thinking about putting the velocity on the right side. Yeah, there we go. So now the axis on the right side is for the velocity, the orange line, and the axis on the left side is for the hertz, which makes it a little bit.
And then based on time as
yeah, the y-axis, the x-axis is time. Yes. So we can add this one, which is so you can see over time how your building was vibrating. And then I think a Gauss sensor would also be interesting, because that looks like this. And there we can configure our values.
Is it dynamic? It'll show the movement, or it's pretty...
Yeah, so every time a new value comes in, this gets updated, and the time series one as well. So every widget gets updated from the moment new
Real
data.
time. Yeah.
Yeah.
That's nice.
So let's configure these values, so 30 and 60. So we have our velocity ranges for the 0 to 20 hertz use case. We can add that to the dashboard as well. And of course, yeah, we can scale these widgets as we like. We can organize them as we want to.
It's very customizable.
Yeah, exactly. So this makes it easy to create a dashboard that you want to show off. All right. And at the end, you just publish it, give it a name. For example, vibration. And then we have our dashboard here in the drop down, and we can just create a new dashboard if we want to.
It's very simple. We just created in a couple of minutes this dashboard.
Yeah, exactly. And the cool part is you can also share it. So if you go to manage, you can set it to public, and then you can just click the link icon over here to share your dashboard with anyone.
And if I am a building management company or a road transportation company, I can have different businesses see different type of dashboard. Can they can they have their own customized dashboards?
Yes, of course. So in the beginning, I created this house dashboard, right? But you can have one of these environments per customer, for example, for each customer. The cool thing is also we now have a dashboard of this building, but we also can make dashboards on the group we created. So we have the house group. Within that we have the vibration building, which in hindsight I would have maybe could have better called like vibration sensor or something.
Yeah.
But on the house group we can also create a dashboard. And if you have multiple sensors, you can, for example, show the vibration sensor, but also the tilt sensor and humidity and temperature values, for example. And then when you click on the sensors itself, you can show a more fine-grained look on these values, like we did here.
That's neat. And also, looks like you can see the alarms also on this. So if
Yeah, very well noticed. So if you click the alarm, you can see the same alarms as you see over here. Oops. As you can see, need to go to the right resource, as you can see over here. And you can do the same action, so acknowledge, clear.
This is very good because I see that you just created this entire dashboard without writing a bunch of code. So which is very, very cool.
Yeah, exactly. That's one of our goals, of course. Low code automation, where you don't have to code everything. Just get started with doing your use case.
Yeah, what will be really cool is that if you just tested with one sensor and now let's say you want to apply that rule template to multiple buildings, then one can easily simulate. If they have a group of buildings and they're owners of a group of buildings and they want to apply a rule template and see which one has the most risk, because they can create a risk profile of this entire complex of buildings that they have, and then take action. They can prioritize, they can get their budget, and then they start working on them. So this
Yeah.
template can be applied to a group in a bulk.
Yes. So I don't have a bulk of buildings at the moment,
Sure.
but it is possible to do that. Yeah, you can just initiate. You can say, okay, if I have resources of type building, for example, I want this template to automatically run on those, and then it will automatically do that. And you can do the same for the dashboarding. So you can automatically group buildings within a dashboard, and you can automatically have or apply this kind of dashboard to those as well, without having to create it from scratch every time. Oops.
That's very nice.
Yeah. So for example, we have a templating function right over here, so you can save a template for this vibration sensor dashboard, for example.
Very cool. Actually, I can see a lot of use cases that can be built on top of this as well. Like say, for example, you said you can have other sensors. Like if you have a weather sensor and it can get weather for next 10 days, then based on the weather, and it's a mountainous region, let's say it's Colorado or Alaska or someplace where there are lots of mountains, even in California, where it rains and then there is mudslide. So then we can predict using the prediction sensor, right? And then we'll say, hey, it's going to rain there in that mountain bypass, and there is possibility of a landslide. So you can predict landslides, and that will help a lot on the road transportation, public safety, and other kind of use cases. I see.
Yeah, exactly. And we do have those sensors. Yeah, we can get the current weather conditions, but also do a forecast. And these use the Open Weather API. So you will have to get an Open Weather API key and then just apply it over here. Say in which city you are, and then it will give you the conditions where you are at, or where the sensor is trying to measure it.
Like that open weather key, that means the API calls are all very secure. So you use secret keys for API calls, for every API calls.
Yeah, exactly.
That's good.
Exactly. All right.
I'm very impressed because you build a low code console and you build a no code dashboard, and you didn't touch to write a lot of code. So I think that's very impressive.
Yeah, I showed you a bit of code, but we didn't touch any of it.
Yeah. And of course, behind the scene there has to be some kind of scripting and code, but it should be much easier to take a sensor code, copy and paste, and write your changes and then test it. So we have a very nice environment that you showed on the IDE. You can test it and then you can deploy it in production.
Yeah, exactly. And all of these little nodes over here get run in a Kubernetes cluster for the more technical people watching. And these are scaled automatically. So if a lot of people are using the range sensor or the range node, for example, then we deploy more of them. So it's very scalable to bigger solutions, but also very applicable to small solutions if you only have one building, for example.
And it can run on any cloud?
Yes, it can run on any cloud. For Waylay IO, we run it ourselves, but for the enterprise part, we can run cloud agnostically, practically. Yeah, which is pretty cool.
This is very cool. Thank you,
Right.
Sander.
Yeah.
It's
I see we are kind of running out of time, so I want to really quickly recap what we have done. So we created a resource for our building where we collected data about the hertz and the velocity. We defined a template that just does some range checking and in the end throws alarms depending on if this is a minor or a major damage report. And if the values are not in range or not too high, then there is no problem. So we don't report any damage. In the end, we threw alarms, we threw major alarms, we threw a minor alarm. And after that, we created a nice dashboard so we can view what is happening to our building, and we can also share the dashboard with everyone so they can see what's happening as well for all the stakeholders, for example. Can have a look there as well.
I think it's a great tool. It's actually a really good low code, no code platform that can apply to many different use cases. Just happen to pick the building vibration as one of the use case, but it is applicable. I see it is applicable to all kinds of like monitoring and safety.
Yeah, exactly. Monitoring or automation or dashboarding. It's
Yes,
very
it's you monitor, you automate the response, and it's a very horizontal looks like because it can apply to any vertical, right?
yeah, exactly. We can go from monitoring to predictive maintenance to just home automation or garden automation. It can go very broadly. The use cases we
Looking
have
forward
seen,
to new use cases from you,
yeah,
Sander.
from everywhere. Okay, awesome. Then the last thing I want to say is thank you, Arabinda. Thanks for being on the show. Thanks for being the first guest to try out the Waylay Autoshop.
It was a
And
privilege. I'm very happy to be part of this, Sander, and it was great that you showed it and made it look so easy.
well, it is
Even I
easy.
can do that.
That's our job to make it easy, of course.
Thank you.
All
Thank
right.
you, everyone.
And then if you want to get in touch with me, just shoot me an email with the email address on screen or tweet at me. Or if you just want to get hands-on with the platform, follow the link over there www.waylay.io, and yeah, take a free trial. And I hope to see you soon.
See you.
All right. Bye, everyone.